welcome to another episode of Clean Tech Talk. I'm Zach Shahan, CEO of CleanTechnica, and joining us today is Dr. Denis Phares, CEO and founder of Dragonfly Energy. So, Denis, we're going to get into some, potentially transformative, very innovative battery production and technology issues from your company. But to start off, I like to just get a little bit of background on where you came from, how you ended up at Dragonfly Energy, what you've done in your career leading up to this point.
Sure. Well, thanks for having me on, Zach. It's a long roundabout story, but I'll try to be brief here. My background is technical, and I went the academia route. So after my PhD, I did a postdoc and ended up becoming a faculty member in aerospace and mechanical engineering, first at Texas A&M and then at University of Southern California. And I was working on projects really focused on aerosol mechanics, fluid mechanics, atmospheric dynamics, and eventually got around to nanotechnology and device manufacturing. I worked on solar cells and fuel cells and lithium-ion battery electrodes. I ended up leaving academia back in 2012, moving up to Reno, Nevada, and getting an MBA and starting Dragonfly Energy, where I really started honing in on aerosol-type processes to produce lithium-ion battery electrodes, anodes and cathodes. Started Dragonfly Energy, went to market, established a brand called Battleborn Batteries, and been working on it for the last decade.
Very cool. Excellent background. Expect nothing less from a former academic and, someone who knows how to present things in a good, efficient and logical way. But yeah, that's interesting background. And it's not exactly typical. We get a lot of people who obviously spend a bit of time in academia, but they try to quickly jump into the business sphere. So it sounds like you sort of you took a little more time before you decided. What really pushed you or triggered you? What got you to think, hey, I actually want to go into the private sector here?
Yeah, I had no intention, none, of going into business. I actually liked teaching. I liked academia. It kind of evolved very slowly. I was a professor for about 12 years, and developing technology and writing patents and getting to understand how you take a patent and commercialize it. It led me down the road of licensing and how universities treat their intellectual property, and it actually was frustrating for me. I wanted to be more involved. I wanted things to move faster. So I ended up the first time I founded a company, it was as a professor, and it was really just to take a provisional patent and make it a non-provisional patent. I mean, that was it. That was the only reason. And then I kind of got some SBIR funding, and this was a previous company working on dye-sensitized solar cells, and I just kind of got the bug, I guess. And after a few years of doing that, I realized that trying to run a company and being a professor, I was just kind of not being optimized at either. So I said, all right, I'm going to try my hand at business, but I wanted to do it right, and that's why I went and enrolled to get an MBA.
Yeah, I remember covering dye-sensitized solar cells. This was like covered them more 10, 15 years ago.
Yeah.
So probably may have covered you guys. I'm not sure. What was the name of the company? Or?
The name was called Tysol.
Oh
And
yeah, I think we.
yeah,
I
do
think
you
we covered it.
remember?
Yeah, I know
It
we
was
covered. Yeah,
it was an aerosol-based process, actually,
and
making
I know we
titanium.
covered some that had spun out of Fraunhofer Institute
Hmm.
in Germany, but I know we had covered several. So it was sort of it was a pretty popular topic for a while, and sort of died off. I guess it's just the issue of conventional solar cells just getting so
Cheap.
efficient so rapidly from
Yeah,
the learning
it was a
curve.
cost thing. I mean, at the time, silicon was so expensive, and once that came down, a lot of those third generation technologies went by the wayside. But Yeah, dye-sensitized solar cells were really interesting just because they looked so
Okay.
cool and they were,
Yeah.
transparent.
Yeah, you can imagine running a news website like this. They were like gold. These colorful, cool solar
Right.
cells. Everybody loved to look at them and write about them. But really, I mean, yeah, the solar industry used to be really. I mean, not that it's not now, but it used to be. It was really fun to cover like 10, 15 years ago when so much was
Mhm.
happening. There were so many innovations and potential ways forward. But just the experience curve, the learning curve, economies of scale, and just basic economics just brought solar cheaper, conventional solar cheaper and cheaper and cheaper and cheaper, and innovations that get probably too little attention in the background, but still, it's interesting stuff. But I can imagine it's always interesting to sort of cover, you cover the institute stuff from NREL or L, Lawrence Berkeley National Lab or different places, and you cover the startup spin-offs and stuff. But it always does seem like a little bit of a funny system how you try to commercialialize innovations and inventions that come out of labs and universities, and the process of a lot of professors just guiding one student after another until they sort of find something that clicks for them, and they're like, oh, maybe I'll do this now. But it's got to be a little bit like it's not I guess the kind of valley of death. It's a very difficult thing to take it from that really exciting lab phase to getting funding and launching a company to scaling up. Were you Yeah, what can you talk a little bit more about any frustrations you had with that, or any concerns you had, like seeing how difficult it can be to go from an idea that you can write and talk about ideas all day long as a professor to actually having to make something work commercially.
I think my biggest frustration in the whole process was the lack of an ability to vet technology, and that really goes even at the academia level, where you have a peer review process at the funding agencies, and I think even that process can be flawed. I just don't like the one way blind process. It should either be out in the open or double blind, because otherwise I think you run into issues with objectivity. And then at the funding level, I think it's too easy for investors to rely on the name of the institution. Like, there's professors at MIT or Berkeley or wherever that, the benefit of just being there, it gives credibility to funding technology. And you've got a lot of these spin-offs that are able to get a lot of funding, even sometimes go public, and really the technology doesn't come to fruition for a variety of reasons. But ultimately, I think it's too easy to justify funding by the institution than actually vetting technology. And I think that's been a hindrance to progress in this country.
That's really interesting to hear, and like get a little bit of behind the scenes on this. And there's definitely certain things that government funding has supported that certain people have like seen, like, oh, this is not going to go anywhere. Why are we wasting money funding this? At the same time, there are so many things that we have in our modern technology that was started by kind of moonshot crazy
Yeah.
funding of the government, especially decades ago. And so it's like you never know exactly, but like we have a writer, Michael Bernard. I'm not sure if you're familiar with him, but he's very good and very keen on sort of like breaking down technical ideas, technical product ideas and startups, and sort of being like, this is never this is never going to work. I mean, he tends to pick things to like, this is, if you get down to it, this is never going to work. And he's done that repeatedly for over a decade with stuff that Google funded, that other people funded, and is like consistently right. Of course, more often than not, it doesn't work anyway. So it's like, not saying Michael doesn't, he does an amazing job, but it's very seldom that a new technology or kind of my breakthrough idea is going to end up breaking through. But at the same time, it does seem like there's a little bit of an issue with too much stuff sliding through and getting funding, whether from the private sector or the government, that really is fundamentally clearly flawed if you get the right person looking at it and explaining why it's flawed, right?
Well, I think what you described before is more of a Manhattan Project type funding situation where you throw money at a team and you end up developing things that were not the primary focus. And I think that's where government is so important in terms of funding fundamental science. That's no investor is going to fund fundamental science. They're going to fund a business idea they want a return on their investment. And I think that's where when the government starts trying to determine what is going to provide a return on investment rather than what's going to advance fundamental science, that's when you kind of get into problems. So I
Yeah,
think that
and going back to the Obama era too, like they funded a lot of different private sector stuff, but in a kind of smart venture capitalist way of like, okay, we'll fund these 100 things, something's going to work, and
mhm,
some things did, and their ROI was actually phenomenal. It was like any VC would be happy with the return that they got with that approach. But a lot of people didn't understand exactly that approach, like that there's going to be failures. There's going to
mhm,
be, Solyndra was the big one that was highlighted for ages. Like, of
mhm.
course, there's going to be companies that got funding that failed, but there's going to be other companies like Tesla that end up shooting through the roof. So it's, yeah, interesting stuff. But okay, we're here for Dragonfly. I'm sorry, it's just there was such
It's
an
an
opportunity
interesting
there.
conversation, you know. It's
Yeah, no, there was such an opportunity there. I wasn't planning on it, but once you started talking, I was like, oh, this would be really interesting to get a behind the scenes kind of insights into what goes on here. But yeah, let's get to Dragonfly. So, um, if I understand it right, you have a kind of innovative dry electrode battery production system going on. So I'm not going to I'm not going to make myself look like an idiot. Let's just have you explain what it is and again where it came from and where you think it's leading.
well, it came from my background in aerosol mechanics and device fabrication. And if you look at a lithium-ion battery, anode or cathode, it's comprised of uh, micron-sized or sometimes even nano-sized particles on a collector, metal foil current collector. So the process of getting a particle film grown onto the metal foil conventionally involves making a slurry, dissolving a polymer glue in a solvent, and then pasting that slurry onto the foil and then evaporating the solvent. And when you evaporate the solvent, it has to be evaporated very, very slowly. So at mass scale, what that means is you run it through a drying oven, and that drying oven has to be extremely long so that you can have a large throughput but still evaporate very, very slowly. And so the innovation that Dragonfly had developed, that we had developed early on, was basically aerosol deposition of the anode and cathode on both sides simultaneously of the metal current collector, and basically curing that powder film almost like a powder coating process, electrostatic powder coating process. The difference is it's electrically conductive. That's why you can't put an electrically conductive powder in a regular electrostatic powder coater. It doesn't work. So the innovation that we had is basically making it work through feedstock preparation of the powder and then how you apply the powder in a powder coating process.
Interesting. Yes.
Did that make sense?
Yeah. I was trying to follow, and I was like, I feel like I'm getting part of this. I kept going to this like a rice metaphor, like cooking rice. When you cook rice, you got to be careful that you let just enough water get out, but not so much that you have rice stuck to the bottom of the pot. But
That's pretty similar, actually. I mean, if you evaporate too fast, you've got polymer dissolved in the solvent, and you want to leave behind polymer that's uniformly distributed throughout the particle film. And if you evaporate it too fast, you'll actually get inconsistencies as to where the polymer deposits, and so you don't get a really nice adhered film.
yeah,
And ultimately, what you need in a battery electrode for longevity is very, very good adhesion, among other things.
interesting. Yeah, yeah. And then when you got to the part where you talked about what you guys do, I was really trying to figure it out. But definitely some terms and ideas that were new. But it's yeah.
Well,
I think
have you heard of electrostatic powder coating?
You
kind of how
definitely
you
not.
paint. Okay, so it's a conventional way of painting metals where you have a
Okay.
dry powder. You charge the powder grains in typically in a corona, in a plasma, and the charged particles are driven to ground. They follow the electric field to ground, and if the part that you're coating is grounded, then those particles are going to be driven very efficiently and coat very uniformly that grounded metal part. So that's the premise. That's how you can coat uniformly a metal part, and that's kind of what a battery electrode is.
It's fascinating stuff. It's funny because when you're new to this stuff, it just sounds like magic. You're like, well, that sounds like magic. Something you'd see in a sci-fi movie and be like, that's not realistic. But it's yeah, very cool. And I think a lot of people obviously are gonna think of Tesla because Tesla has worked on
Right.
dry elect, and
Yes.
Tesla's gotten 1,000 times more attention than anything else in the sector for years. I was also really tempted to go back. Yeah, well, we'll leave this for the later in the show. Something funny I wanted to go back to, but what can you talk about with regard to Tesla's dry
Tesla.
electrode battery
Yeah.
system
So
versus
dry
yours?
electrode is a general term that really refers to eliminating the solvent from the process. So Tesla acquired Maxwell, I think back in 2019 or something, and Maxwell was producing advanced capacitors. So it's a very similar structure where you have a conductive powder coating a metal substrate. And Maxwell had developed this process called extrusion, where you take the metal and put it through a high shear, high pressure roller, where it's melted into a freestanding electrode film. And then that electrode film needs to be laminated or stuck onto the current collector, the metal foil. And they started applying it to lithium ion battery electrodes. And that's when Tesla got interested and acquired the company for that process. The difference is we're not extruding anything. What we do is we're powder coating directly onto the foil. So that's very different. It's a very different process. I think some of the problems that Tesla has in that process is it's a high shear, high pressure process, which I think is relatively difficult to scale, especially for the materials used in batteries. And then secondly, the lamination step isn't trivial either. What we found is that to get a particle film to have really solid adhesion throughout the entire interface with the current collector, it's not trivial. And for us, we do it by basically growing the film one particle at a time rather than trying to laminate an already formed film onto the foil. So those are the main differences.
Yeah, it's funny when you first described what they were doing. That's what came to mind. I was like, well, that would be difficult. So maybe
Yeah.
I'm sure your description of it like set me up for that idea, led me into it. But it's as a good professor's explanation would. But yeah, I mean, right away when you started explaining what exactly that was that they were doing in that way, it was like, well, that seems like it'd be hard to scale, and that could be get tricky, especially for the level of consistency and quality control that you need to achieve, and then to be able to compete on cost with conventional batteries. And
Right.
I know, yeah, I don't remember how long back it was that Elon said that they were approaching like the same costs as conventionally produced lithium-ion batteries, and they should be competitive, but they would end up using more from suppliers unless they needed to rely on their own production. But it was always like, well, this is a strange kind of turn of events, like a strange kind of change in the narrative here about how revolutionary this is and how big of a deal it is for the company, instead of like it being this breakthrough thing that was going to bring down costs and make them the clear market leaders in battery costs. It was going to become a backup option. So it was never really clear. A lot of us, who follow this, were like, well, what exactly is going on with this? Like, why is it not as much as it was hoped to be? And it sounds like you just explained why. Like, basically, like getting it consistently done well at low cost, scaling it up, it's just too much of a challenge for this process.
Well,
It's,
to be fair, I'm on the outside looking in
yes,
too, so I'm kind
yeah.
of I'm looking at it and
You have no
guessing.
horse in the race, too.
That's,
No, no.
so I mean, it's I think they're close. I think that they actually got it working pretty well. I think, but when you scale,
Yeah,
a lot of cost issues come into play
yeah,
potentially that you might not foresee. For example, when I mentioned that the high shear, high pressure presses, I think that those get worn out a lot faster than conventional
hmm,
calendar presses in the battery industry, and I that's one of those unforeseen costs that could come up when you're trying to scale a process like that. But theoretically, when you eliminate the solvent, you eliminate that entire drying process. It most definitely should
right.
reduce the cost and the energy usage and capex and opex and all that, and make it cheaper. But obviously, the devil's in the details.
So, can you talk a little bit about how your process has gone as far as getting commercial ready, coming to market, that kind of, and scaling up? What's your story right now with all of that?
Well, we've had the opposite difficulties, and we've been capital constrained, honestly. I mean,
Of
the
course, yeah,
one thing that I really focused on when I started Dragonfly Energy was after getting an MBA, I realized that the purpose of a business was to make money. Not
yeah,
not necessarily to develop technology. You develop technology for the purposes of growing the business.
yeah,
So I went to market. I started assembling battery packs. I released Battleborn batteries, and we became very very well known in the RV industry. Uh, and so the success that we garnered there drove us to profitability, and I was able to use the profits to develop the technology and file the patents, but not scale it. I didn't have the cash from profits to scale it. So back in 2022, I took the company public through a SPAC merger, and almost immediately faced some economic headwinds with rising interest rates, and really had to buckle down and focus on the core business and growing that. Expanding our downstream markets. We're now in heavy duty trucking and industrial solar and other markets. So the technology works and continue to work, and we even have a place to put the cells when we make them, but we have to raise the capital to deploy the technology in ongoing challenging fundraising environments associated with higher interest rates.
yeah. So you've consistently just found really niche markets that were sort of underserved,
Yeah.
underlooked at by. I mean, clearly the lowering of battery costs, the rise of lithium-ion battery production has led to phenomenal like revolutions with like electric bikes, stationary energy storage systems, um, electric cars, of course, utility scale storage systems. But there's still a lot of battery markets that are just too small or don't get enough attention that you're like, okay, well, we can help these markets with our technology while they're sort of neglected by the. Is that, am I
That's
portraying?
exactly
Yeah.
right. I mean, how do you compete in home storage with the Powerwall or LG or Sonnen? We're not going to do that.
Yeah. And I
How do
think,
you
go ahead.
and how do you compete in electric vehicles? I think we've gotten quite a bit of attention from auto OEMs, but ultimately those are not battery companies; they're car companies, and they've been burned investing in battery companies. So I
Yeah.
think right now they're kind of going back to the large tier one suppliers and just working with them. So yeah, we've had a very specific focus on those niche markets where we know we can provide a product that is better than the incumbent, which is typically lead acid batteries in our markets, and we make money there.
Yeah, no, it's a fascinating thing on a couple of levels. I mean, like once you're scaling up, this industry of lithium-ion batteries getting to such a scale that it gets harder and harder to compete. I mean, you can't really compete when they're mass producing on terawatt hours level of batteries for major, huge, gigantic markets. Like you explained. I think people understand that, but I just want to tease that out, explain it. But
Yeah.
it makes me think a lot of the solar industry as well, where there were these different innovations that were going to try to improve solar efficiency, solar cost, but just the constant scaling of the conventional technology just made it harder and harder and harder to compete. Um, and then, like you said, there was a phase where automakers invested in, like, yeah, I won't name names, but a handful of like EV battery innovators that got a lot of attention, would be featured in Fortune, New York Times, wherever, and then
Hmm.
it just never panned out. And like you said, they're not battery producers, so it sort of like it wasn't a match made in heaven for
Right.
automakers to invest in battery startups and know what to do with them, right? And then you've got the situation like CATL in China, which has just been rapidly innovating, rapidly scaling. BYD, LG in Korea, and it just I don't know. I would assume on one hand, like one path forward is to get bought and rolled into those companies, but those are Chinese and Korean companies,
Hmm.
and they also, I mean, there's obviously there's concerns, I'm sure, with working in China, and um, and then at the same time, you had this chance, I guess, with Tesla, where Tesla was like leading in this and trying to scale up, but it's also only picking one route or another, and it's got its own issues. It's also not really fully a battery company. So I I don't know. And then like you're talking about with the market, I mean, we had the crazy situation with COVID. We had the investment boom. We had the clean tech investment booms that sort of followed Tesla's profitability and rise, and then we had all these SPAC mergers, which a lot of them were not were not really going to lead somewhere, or maybe it was just the horrible timing where the market was right, everything was pumped, and then everything crashed. So then it made everything that was looking promising and exciting super hard to deliver on, right? So I don't know. What's your yeah? What do you have to say on like those kind of trends and like yeah? I mean, you led me into them with what you said already, but it definitely I can see your story really well, and I I think for people who have really followed these innovations for a decade, they know they all these things click and it all makes sense. But for someone who's sort of new in the past couple of years to this, it's probably hard to like to really picture the full story of what's happened and where you are.
Well, you said a couple things there. First of all, you're right that money used to be free and money is now expensive. I mean,
Yeah,
that's the bottom line. That's what's
yeah,
changed,
yeah.
before 2022. Money used to be free and now it's not. And yeah, that was COVID driven. Um, I do want to point out the way you compete with how if you have economies of scale that can bring down the cost of traditional processes, then the way to compete is to innovate in manufacturing so that you can approach those costs without economies of scale. And that's what the dry electrode process can do. And that's how we intend to apply it. Because you don't have to scale to these enormous, drying ovens and the slurry based process, you can really grow a manufacturing plant in a modular fashion. A lot of in the industry, you typically expect to have to grow to 30, 40, 50 gigawatt hours. But if you can make something that makes sense financially at a gigawatt hour or 2 gigawatt hours, you've got something that's pretty valuable. And there's a lot of different cell formats and chemistries. In our products, we use typically LFP cylindrical cells. It just works for our listings, our compliance standards, and the products that we produce. But you can't get those on a mass scale outside of China. So there's a
Yeah.
lot of different types of cells that you can make money at even without going to the giga scale if you have a process like the dry electrode process that can allow you to build a factory in a financially feasible manner.
That's really interesting. Yeah, to hear that you can compete on a 1 gigawatt hour scale with the technology, presumably, versus having to have a 20, 30, 50 gigawatt hour factory. And yeah, that really puts in a different perspective as well. And just as far as the IRA, the Inflation Reduction Act, and the different subsidies, the tax credits that were in there for battery cell production, battery pack production, battery mineral mining and processing, even, how has that? have you guys, has that helped you guys, or have you worked with that, or is it it's not really where you are anyway right now, or and yeah, and how is it going forward with the
Yeah,
changes?
I mean, it's first of all, it's been really complicated. Nobody really knows how to how to account for it, but
Yeah.
yeah, we are subject to since we assemble all of our battery packs now in-house, even though we're not mass producing cells, we at least are we have some exposure to that tax credit associated with the pack assembly. But ultimately, that hasn't driven any of the decisions that we've made. We want to be able to manufacture domestically and compete with international manufacturers without tariffs and without subsidies and credits. It's ultimately a function of your innovation and how good it is. And yeah, there's cheaper labor elsewhere and there's less regulation elsewhere. But at the same time, it is possible to make things cheaper and apply more efficient processes to compete.
Were you hopeful that at all there would be more battery cell production and kind of battery um, ecosystems here that would help, like just the overall market around
Yeah.
you for your
Yeah.
business?
I mean, the infrastructure is critical. We're still hoping that the infrastructure gets built out. Right now there's only one active lithium mine in the United States,
Mhm.
and we had been working and actually signed an offtake agreement with a Nevada lithium mining company called Ioneer. I think that's probably the next one that will come online. I don't know what 2027, something like that. So we need the lithium out of the ground to be, I mean, fully domestic. You don't have to be fully domestic, but ultimately you need that infrastructure to get the lithium out of the ground, refine it, convert it to cathode active material. And then ultimately we also want recycling, and there's recycling companies that are popping up, and some very interesting technologies. We've got Aqua Metals here in Nevada, um, among others. And so, I think there's an opportunity, but it's going to take some time, and it is going to rely on some global supply chain in the meantime. But we got to get going.
Yeah, I mean,
Let's get going here. We need to build up that infrastructure.
yeah, I mean, we've covered it quite extensively, especially a year and two back. Just how much of the battery market is centralized in China, like
Mhm.
60% of battery production, but then like 90 or more percent sometimes of certain components um, is produced in China. So it's like, yeah, it's very hard, yeah, I imagine to like to pull together like a really good and quick innovating, quick, easy to work with ecosystem of companies and suppliers. But yeah, really interesting stuff. So I don't know. Do you want to explain any more? Obviously, I got a little bit lost when you talked to me about the technological side of it. But do you want to explain a little bit more? Any of the um, sustainability or efficiency or performance benefits of the technology and any more details. I'll just sit here, listen, get lost, and I'm sure some people will follow. I think I followed pretty well last time, but it was definitely at another level of technical um, yeah detail that gets I get lost in a little bit, but I loved it. So and I would love to return to it and try to piece it together more.
So what I haven't mentioned yet is you can do things with the powder coating process that you can't do with the slurry process. And one of those things you can do is powder coat layers. And if you consider having two solid layers on top of each other, the first thing that might come to mind is an electrode that's always solid, but then an electrolyte that's also solid. So one of the things that we've figured out and patented is that you can coat layers of catholite, which is cathode infused with a solid electrolyte, and an electrolyte layer and an analyte layer. So we figured out how to powder coat an all solid state battery, and if it's a ceramic heavy electrolyte, it's not flammable. So one of the things that we've been focusing the technology on, and of course have been capital constrained, so we haven't been able to deploy it, is that you can make a fully intercalated battery, lithium iron phosphate and graphite. By intercalated, I mean there's no lithium metal anode or anything like that. Um, and have an all solid state electrolyte, which makes it cycle a long time because those types of chemistries cycle more than lithium metal based anodes, which are subject to things like lithium whiskers and dendrites and
Right.
non-uniformities and that sort of thing. But now you have a long-lasting, non-flammable battery. And that's what we consider to be the battery that should go in every grid-tied building. We want distributed storage. We want to have as rock-solid a grid as possible. And I think a lot of that is going to be associated with distributed storage and distributed production. So you don't have to have these huge BESS systems. You can also supplement that with just batteries deployed in every home. You you can't do that with the current battery technology with a power wall or liquid electrolyte based batteries, because even if they're safe, they're dangerous in a fire. So it just creates things. It creates hazards for first responders if there is a fire, which the safest battery will contribute to a fire. So that's why we're focused on having a ceramic heavy, low levelized cost battery pack, because we believe that is the distributed residential storage product of the future.
And what about for like commercial, like buildings, office buildings, or those kind of sort of seems like that
Yeah.
could be a good target because yeah, they're sort of. I don't feel like the residential battery market has been growing pretty well, especially in certain markets. But I feel like between utility scale and residential scale, there's not there's not a lot of targeting on these larger commercial buildings, office buildings, kind of in cities, especially in large
hmm
cities.
Well,
So
absolutely. I mean, when we start talking about lithium batteries in high rises, and you know,
it's
uh,
it's not even like
it's not
yeah,
good. Fire
yeah.
departments get nervous. So yeah, definitely that is a solution there. But even from, if you look at the bridge between utility and residential, a utility that wants to put a lot of renewable, intermittent power on the grid should be able to require houses to have a battery in them, but you
Mhm.
can't if there's the liability because of the flammability. So there's a
Absolutely.
hinder. They're being hindered from really being able to, on a mass scale, deploy more renewable energy because of that. It's just not safe enough, and that's why you need a non-flammable, low levelized cost and energy dense battery you can put in homes.
That's really interesting. Obviously, it's easy to get enthusiastic on an interview, a pitch, but I mean, I feel like you're really good at finding the niche, like teasing, like looking for the opening and finding the niche applications, the reasons why something might work or not work. I mean, starting with the whole technological process and innovations you have, but then also leading to finding market opportunities and why something would scale well or not. And it's fun to listen to you talk and sort of see you explain that and tease that kind of stuff out. Um, yeah. Anything else technologically? I think that's really fascinating, really interesting how you're explaining it. Of course, solid state batteries overall have been something that's gotten a lot of attention for 15 years,
Mhm.
and I think a lot of people are jaded because it's like
Yeah.
this solid state startup or this one, and then automakers talking about how they wanted to leapfrog into solid state batteries, like
Right.
Toyota or whoever. And I think a lot of people feel jaded, but then don't particularly know necessarily what to look for, what to look at. And the way you just explained your process and how that would help, to avoid dendrites and capacity drops and issues inside the battery system. To me, it sounds really convincing and clear and helpful. Bringing into consideration all the other things you talk about, levelized cost. So I don't know. It's very exciting and promising. You've brought up capital constraints a couple times. What is your like? What are you looking at now as far as how you go about, you know, trying to get the necessary capital and scale up? Obviously, you're talking to me for a reason, but I don't know exactly like what you're looking at for how to get that extra funding and scale.
Well, I mean, honestly, we've been shouting from the rooftops for the last 2 years about the technology, and so we haven't gotten a ton of attention as a company because we're so well known as an RV supplier. as a battery pack, manufacturer, battle-born batteries, and it's not
Well,
well understood that.
the last few years have been brutal too.
Yeah,
I
oh,
mean, like
absolutely.
it's just like 5 years ago, you'd be on the front of Time magazine probably. Now today, it's like, especially. I mean, I feel like it's changing. Maybe that's why we're on a call. But like past few years, it's just been a brutal market for this kind of thing, right?
Well, we're fortunate that we have a core business and revenue. Not a lot of battery tech startups have revenue. And so we there was certainly a significant RV correction that was amplified by high interest rates that we had to deal with, and we had to diversify our markets pretty quickly, and we had to hunker down. I mean, that's we had to do that. We couldn't go and scale promising technology because we just didn't have the cash and there wasn't cash readily available. And that's okay. We feel fortunate that we actually do have a thriving business. But I just want to go back to one thing regarding solid state and how people are jaded. I want you to notice that I never mentioned electric vehicles when I talked about our solid state because I don't believe it would make a good electric vehicle battery. It's not a high power battery. It's not a 5 minute charging battery, and it's not the most energy dense battery. I'm just looking at solid state in a unique way in that it can be made completely non-flammable, but it can also be made so that it lasts many cycles. And that's more of a storage battery, more residential storage. And I don't think that solid state has been considered as such. The focus with solid state has always been on fast charging and driving, 800 miles on a charge. That's been the focus, and that was not our focus.
Yeah, that's really interesting. But again, like you brought out the part of utilities should want batteries in every house, but they
Mm-hmm.
can't really tell everyone to put a battery in their house without taking on the fire liability of that.
Right.
And, bring that, I mean, that's just a weird kind of minute kind of detail, that you don't necessarily think about until you're trying to go down every step of the chain of logic or something. And it is a really interesting point. Like it, yeah, if you have a solid state non-flammable battery that utilities and whatever can require be part of new residential construction or whatever, that's pretty like a it's like one of those weird like small game changing factors, right? Like there's so many industries that have scaled up or become huge, and like the basics of it, but it's often like one weird kind of factor or turning point that sort of clicked that made it happen, right?
Yeah, it's exciting to think about getting everything renewable and just going there, but I think that the dangers of that are exemplified by some of these large BESS systems that were, for example, produced with NMC batteries, the most flammable chemistry out there. I think that as things evolve, you realize that things could be done better. And maybe rushing into certain technologies, it could potentially be misguided, but sometimes it works, sometimes, so I don't have a crystal ball. I wouldn't have known what to say at the time, but I think it's unfortunate that there's been some of these high profile fires, and EPA is stepping in with new guidelines for BESS systems, and I think that's fine, that's great. But we just need to focus on doing it right, and making sure that in the long term it's economically feasible, however we address this energy issue.
Yeah, great stuff. This is a really fun talk. And yeah, when I was talking about the past few years being brutal, I wasn't actually referring even to the economics and the financial markets, although that's obviously as well, but just the media, the coverage, the kind of like there's different hype phases of technologies, and there's like we went through a big hype phase, and then that sort of crashed, and it's just like it's very hard to get attention for something that would have been getting a lot of attention 5 years ago, would have been really hyped up. Now it's like even if you have like the best idea in the world, it's like, okay, yeah, we've covered that before. We've talked about that kind of thing before, or I mean, this is our business to talk about this stuff, so it's different for us. But even in our industry, even in our business, there's been a shifting away from one thing to another. But it is really interesting. So last thing, I don't know if we should go down this road, but it caught my attention. So you talked about being a nanotechnology scientist. There was a weird, like long before Elon got into, well, it's the first time Elon tweeted one of my stories, Elon Musk. It was one of like 4 tweets in like 2 months. Like he tweeted like about SpaceX, about Tesla, tweeted one of my solar energy stories, and tweeted something else like 15 years ago or something. So dude was not very vocal, not very active on social media, and over time, obviously, he's gotten much more engaged and controversial, to put it mildly. But before like this kind of phase of like extreme political activity, conspiracy stuff, he got into a fight with a nanotechnology scientist like on Twitter, like I don't know, it was 6 years ago or something, and he claimed that nanotechnology wasn't a thing. It wasn't didn't make any sense. There's no such thing as nanotech. And it was this really weird fight that he had with a nanotech scientist who was like trying to explain. She was like trying to explain that it was a thing. I'm just curious what your take is on what nanotech is and like what it means to be a nanotech scientist. You're probably like, why are you dragging me down this road? But this is
No, I
just a
don't
weird
mind.
fun. I don't know. I'm just
Honestly,
curious.
honestly, Zach, I don't think it means anything. I mean, everything that everything, whether you're developing something in physics or chemistry or whatever, you follow the same conservation laws. It's all the same stuff. So what is nanotech? It's nanoscale structures, maybe the onset of Buckminster fullerenes and carbon nanotubes and different chemical formulations of carbon brought in this new field, nanotechnology. But really, they're large molecules that have interesting properties. It's just chemistry. So yeah, there's buzzwords. I guess even solid state batteries is a buzzword. But it's just I think some of these buzzwords are developed to make it digestible. That something interesting is happening to the public, and maybe it helps investors to fund the next hot thing. I don't know, but I kind of agree with Elon Musk on that point that nanotechnology doesn't really mean a whole lot because nanoscale phenomena have been around forever, and we just kind of focus that buzzword on a specific formulation of things.
But is nano would you classify it as like a certain scale, a certain size of technology, or is it not even that? It's not even like a certain like you know size of technology.
Well, that's
Physical.
I think nanotechnology refers to technology focused on structures at the nanoscale, the nanometer scale,
Yeah.
right? So, which is it's a little bigger than the size of molecules or atoms or the size of large molecules. I mean, I think that for a while, carbon nanotubes was a really
Yeah. That
popular
was.
thing, and
Yeah.
people were writing research proposals by infusing whatever with carbon nanotubes, and even if it was meaningless, it had the
So,
word, so it got money.
so you were
you know?
proposing. Do you think it was like the fascination of the obsession is not the right word, but with carbon nanotubes that sort of formed this idea of nanotechnology? I mean, this term, this scale. I mean, it seems clear to me like there is a kind of scale that it covers. Like
Yeah.
it's stuff that's not smaller than that and stuff that's not larger than that, but it doesn't really have a. As you're saying, it doesn't really matter. What you're working on is what you're working on, and
Yeah.
it's not
Yeah,
like it's not
I
like a
mean,
market. It's not like a housing market, like nano market. It's like
I myself used the term nanotechnology
yeah,
at the beginning of this
that's
interview.
what got me in.
It's we're used to using these terms, but I think nanotechnology referred to a lot of different things, and I think yeah, most prominently it was carbon structures like carbon nanotubes, but it's been referred to things that are just very small. Microfluidics. Is probably has some nanotechnology infused in in that area of research. I don't know. I mean, I think that it's just words. The only thing that is meaningful is the physical conservation laws that underlie everything. And if you come up with an interesting process or an interesting material, call it what you want. But hopefully it does something novel.
Sounds good. Interesting. I like your your answers always sort of make me feel a little bit like I'm in a college classroom again, which I love. I loved the academic world, academic life, and sort of kind of break down constructs in our mind that are a little too. We form concepts and walls and constructs that sort of limit our ability to think, right? That sort of limit our ability to go beyond and find new pathways, right? So it seems
Hmm.
like you're really talented at doing that. So props to you. I think sounds like a really exciting venture you're on, and really excited to see where you go. Hopefully to the moon and beyond. So thanks for sharing your time with us today.
My pleasure. Thank you, Zach.
Thanks.